Welcome back, Honors. Welcome back to it. Welcome back to your Flip Classroom and our continuing discussion of the scientific revolution, right? And me being a phony. Yeah, I know I said I was going to post this and stuff like that on Friday, but I forgot. I'm sorry. We all make mistakes. Now, big thing about it, though, is I'm actually in the process of grading your tests and stuff like that, so those will be posted probably around, by the end of the day, Monday. All right, so, now, big thing about it, though, is we also want to go ahead and dive headfirst in this flip. We don't always do this, right? We don't always have a flip, right after a test, but I want to stay on track, and y'all are ahead of the game right now, and if y'all stay ahead of the game, then we can keep up on some of those promises, right? Some of those ideas and maybe, going off campus and doing something cool and stuff like that. But the big thing about it is y'all just got to keep working hard for me, and I'll work hard for y'all, right? Well, do me a favor, go ahead and watch the clip of this flip that I recorded actually earlier, not earlier this year, but last year. It's really, really good, where I talk about the new scientific method, Rene Descartes, Sir Francis Bacon, Andreas Vesalius, and the growth of the scientific revolution. But I'll be back here in about 2 seconds to talk about some new updates that I've actually done, talking about a couple of guys that invented something very, very cool that I used to have one of when I was a kid, and I used to be obsessed with it. And then also we're going to talk about this other guy who's going to come up with a lot of different ideas, mathematically speaking, that are going to link the sciences together, right? But I'll see you in a second. Created, right? Because of everything that's been going on and because of the beginning of the scientific revolution, and even before and while Galileo was working on all of his stuff with all these things and his telescopes and the moons of Jupiter and everything else, what was going on as well was this breakthrough in a scientific culture. There is now a culture moving throughout Europe that actually is hinging and focusing on science, and everybody is beginning to base a lot of their new things, their new ideas, things that they are learning on literally observation and experimentation, rather than focusing it as well on assumption and church law, right? So the big thing that we need to talk about first is two couple of guys that are going to start kind of going in that direction of questioning everything around them and trying to find out some new results, right? So the very first guy is a man named Francis Bacon, which ironically enough I don't have a picture of him, which is super, super annoying, right? Francis Bacon, though, is an English scientist, okay? In your mind, I want you to think about a guy that's got a mustache and a little triangular beard and stuff like that. He always wore a hat, and he actually worked in the parliament in England, right? Worked in the parliament as a finance minister and stuff like that. But Francis Bacon is going to become really, really big, not because he invented bacon, because he didn't do that, but actually Francis Bacon is going to become very, very important because he's going to begin to pioneer a new conceptual idea about science and how it relates to society, right? He's going to actually dictate the ideas in several of his books, one of them being a book called New Atlantis, right? And in this book called New Atlantis, he talked about how there was going to be basically a big building that was almost going to be like Hogwarts, right? Like Hogwarts, where Harry Potter lives. Except there's not wizards there. There are different types of people there. There's scientists there. And people would bring their problems to them, and the scientists would actually create a system of experimentation, a hypothesis, and coming to a conclusion to solve the problems of the people, right? So what Francis Bacon has basically done is he has actually invented, in a nutshell, the scientific method that we use now, that we actually y'all use in your chemistry class, in your bio class, and in your labs, where you're okay, I think this will happen. Let's design an experiment to see what happens. Let's observe the results of that experiment, and let's come to a conclusion. Francis Bacon is the one credited with kind of coming up with that system, systemology and stuff like that. Now, another dude, though, is going to come along. He's going to be very important, and he's going to have one of the worst haircuts you've ever seen in history. But his name is Rene Descartes, all right? Rene Descartes is going to take the ideas of the scientific revolution, and he is going to begin to kind of grapple with the idea of human reasoning, right? What do we really know? What do we really know about the moon and the earth and ourselves and all these other things? And he's actually going to try and figure out ways to use human reasoning to diminish doubt, right? So he's a mathematician. He comes up with new geometric values. He actually comes up with a lot of different things when it comes to mathematics. For example, Rene Descartes actually invented this thing called the Cartesian plane, right? The Cartesian plane is the X and the Y axis that y'all use when you're in math class, because literally one night he was laying on his bed and looking up at his roof, and a fly was buzzing around the roof and going bzzz, bzzz, bzzz. Like y'all seen probably before, it's New Orleans, right? Y'all literally run into mosquitoes, flies, and all kinds of critters around down here. So the thing about it is he saw it and he's like, wait a minute, if I made a series of lines going left and right and up and down, I could plot where that actual fly landed and stuff like that. And he basically invented the mathematical planes, the X, the Y axis, and stuff like that you use in all of your mathematics classes. But another thing that he's best known for is the biggest thing of his philosophies, right? He did a ton of new types of math and things like that. But then one day, he actually looked inward and he was like, wait a minute, I've come up with these new ideas of mathematics. Galileo is coming up with these new ideas about space and like the universe. And then like Bacon is coming up with scientific theories. And the world is growing and changing. And everyone is learning so much. But then he's like, but how do I even know that any of this is real, right? So Rene Descartes then began to grapple with the concept of existence, right? He actually tried to figure out, he's like, the human mind and this world that we live in, are they one and the same? Does my mind and consciousness exist in this place, or does it exist someplace else, right? Is it a part of my soul? Is it a part of my reasoning? And he started freaking out, and he was just like, am I real? Am I real? Is this real? Is this real? Is this Flip that Mr. Terry recording right now? Is it real, right? How do I know when I come to a stoplight, when a person turns to the right and then they're gone forever and I never see them again? How do I know that they even exist? Word on the street is y'all talked about this a little bit in Mr. Mathern's class, and something that kind of freaks you out and it leads to an existential crisis, right? Because really quickly, how do I know Mr. Mathern's real at this moment, right? Well, Descartes begged that question constantly. And he said to himself one day after emerging from his basement, he said in Latin, cogito ergo sum, which is a very famous quote that you should have tattooed in the side of your face for the rest of your existence from this class, and it's very important. Descartes emerged from his home one day and said, I have to exist because I think, therefore I am, right? He said if you have rational thought, if you've got thoughts whirling around in your brain and stuff like that, then you must exist someplace, right? You must have existence of some type. But the thing about it is you just can't prove that anybody else or any other thing exists in and of itself. So cogito ergo sum, I think therefore I am, right? Rene Descartes, though, phenomenal intellect. Very, very important. And make sure you get that I think therefore I am thing. Then set your tattoo appointment up as well. Then there's also going to be massive breakthroughs in medicine, right? So medicinal things are going to be massively linked to the scientific revolution as well. So the medicinal aspects of it are actually going to be linked directly to a couple of particular scientists, doctors, and other people as well. Like a guy named William Harvey out of England is going to be really big for realizing that the heart actually works like a pump and actually pushes all the blood through your body. He figures this out actually using a process known as vivisection, where he would dissect animals while they were still alive so he could see the heart actually pumping and moving, right? But scientists and doctors are going to begin to kind of go along this new line and idea of dissecting bodies and performing these things known as autopsies, right? Trying to figure out how the human body is constructed, where is everything connected, where do our bones connect to themselves, how do they stay inside of our body, why is our skeleton not leaping up and running around, what's our skeleton look like, things like that. Well, the first guy to come along and do this, before William Harvey does his vivisections, before all these other scientists really get into it, that actually begins to kind of go against church law is a man by the name of Andreas Vesalius, right? So Andreas Vesalius is super, super important because he's not deliberately going against Catholic law and Christian law. But it was a big thing that we need to understand, that for many, many, many eons, it was against religious law to dissect or actually kind of do anything to a dead body. You had to go through a process, a religious burial and stuff like that. So no one ever really got the chance to open one up and see how everything worked and what it looked like, what muscular structures looked like, what were the internal organs, skeletal structure, the circulatory system, the nervous system. How does all this stuff work? Well, then one day, Andreas Vesalius comes along, and he creates one of the very first medical books on anatomy. And this is Andreas Vesalius right here, and an engraving in one of his books. And as you can see, he's peeling back these veins so he can see how the vascular system works inside of this dead body, and he's performing this autopsy, right? He removes the skin so he can see what the muscular structures look like. And his book is a very, very powerful, very, very big tome known as De Humani Corporis Fabricum, right? So if I literally go okay, that's a warm-up. De Humani Corporis Fabricum. So the big thing about it, though, is this book is literally known on the fabric of human beings, right? And the images inside of it serve as like the first medical textbook. It's so, so cool. Like, look, he's like literally got these different like elements of people being like kind of like standing up and stuff like that after all the skin has been removed, so you can see what all the muscular structures look like. I've actually seen one of the original copies of this book in real life in Philadelphia. It's at this place called the Mutter Museum. It's super, super cool. And he actually hung up the bodies and stuff like that so you could see how everything worked. This is one of my favorite ones right here. These two pictures of a skeleton and everything like that. And I'm just throwing this out there really, really quickly. Like this one in particular, you know, like I could never get a tattoo because I'm terrified of needles. But man, if I did, I really think one day I would like one of these guys just to kind of like connect to my teaching and stuff like that. But that is Andreas Vesalius, and those are the concepts that he comes up with. The idea of performing autopsies and dissecting bodies and trying to figure out the muscular structure. Now, funny enough, too, his very first books, his very first copies of the book, De Humani Corpus Fabricum, were actually bound in human skin. Instead of using cow leather to bind his books, he had so much extra human skin lying around from all these autopsies, he had it But yeah, so welcome back, okay? Thank y'all for watching that little clip of the flip. I really, really appreciate it because it was really, really solid, where I talk about a guy who made a book about dead bodies and body parts, but then binding it in skin. Now, going into it, though, when we're looking at it, we also need to know that the scientific revolution is going to keep growing in advancements, right? Some advancements both technologically and method speaking, right? So, like, now, big thing about it, though, is this device right here is going to be very important when you're talking about the growth of the scientific revolution. That bad boy is one of the earliest microscopes, right? I know it doesn't look like one, and it looks a heck of a lot more like a ping pong paddle, but it actually is one of the earliest developed microscopes. And that one right there was invented by a guy by the name of Anton von Leeuwenhoek, right? Anton von Leeuwenhoek is a Dutch scientist who will develop that little goofy-looking microscope, as you can see right there, right? Which actually, when you look at a picture of it, you think it's a lot bigger than it actually is, but it's a little tiny guy, right? Well, Anton von Leeuwenhoek is actually going to go in the reverse of the way the scientific revolution went, right? When we started off with the scientific revolution, we were talking about our place in the universe and our location in space and like where we are in that great, giant, ethereal nothingness void that Fairchild's so afraid of, just like I am. So now, what we need to understand, though, is now we're getting into the smaller universe, right? The universe that is beyond the naked eye, that is, like, of course, made up of things that we can't even see, right? Well, Anton von Leeuwenhoek is going to perfect his version of the microscope, right? Now, the big thing about it is he didn't invent the original microscope. There had one that came before him and stuff like that, but he actually perfected this device to have a smaller and more acute concave lens that'll actually give him the ability to see further into certain specimens, right? And he's going to use his microscope to actually be the very first person to view protists, which are like small little creatures that live in water, and even some forms of bacteria, right? And he's actually going to see this in pond scum, right? So he's actually going to see, like, literally he's going to take a little bit of a dollop out of a pond, and he's going to put it into a slide and put it on his microscope, and he sees all these little critters moving around that no one's ever witnessed before, right? So he actually took it in the opposite direction from looking at our universal perspective into understanding those tiny little organisms that live beyond us, right? He even was the very first person to observe spermatozoa and several other different things inside of his microscope as well. Now, another guy, though, is going to come along, and he's going to perfect another version of the microscope, and he's this gentleman right there, right? His name is Robert Hooke. He is an English scientist that is going to create a microscope that you're a little bit more used to the way it's actually styled, right? See this bad boy right here? Looks a little bit more like the ones that we have in the labs and stuff like that at school, okay? And he's going to perfect another microscope that's going to have a lighting source that's actually going to use a refractive magnifying glass to actually source light into the specimen itself. And he's going to use his to actually advance, advance the study of the microbiological world, right? And he's going to observe, of course, you famously probably learned about him when you were talking about him in biology. He observed cork cells, right? He actually observed cork cells from the bark of a tree, and then also from the actual corks of wine, and he actually saw these little things, these little cells that actually made up the actual specimen itself, right? And he actually is going to begin to deduce the fact that the building blocks of tissue and things like that are actually made up of these very small things called cells. And he called them cells because it looked like they had defined walls, right? And so going into it, though, also looking at this is one of his drawings. Something we need to understand about Robert Hooke is he was a very, very good professional when it came to documenting the things that he actually saw under his microscope, and he would draw them. He also actually has some of the most like acute drawings of like insects and things like that. There's one actually of a fly's eyeball that he did, and you can see the hexagonal pattern of the eyes. And this right here is an actual image of his microscope, right? And then, of course, this one right here is one of his most famous drawings. That, of course, is the drawing of a flea. You know, that little insect that famously carried the Black Death. Well, speaking of the Black Death, we got to talk about another guy, right? This dude is going to come along, though, actually a contemporary of Robert Hooke's, which means they work together, right? A contemporary of Robert Hooke's, and he's going to come along and he's going to advance the field even further, okay? But he's going to devise something that's going to be a scientific construct that's going to be proven with a mathematical construct, and all of these sciences become linked, and it's like the ideas of Galileo are finally proven using mathematics, right? And this guy is none other than Sir Isaac Newton, right? Isaac Newton, that guy, you famously heard the story about this apple hitting him in the head and stuff like that, even though that actually never happened. But going into it, though, we now have to talk about Sir Isaac Newton, right? Isaac Newton is an English scientist who actually worked directly alongside of Robert Hooke in different fields. They actually didn't get along well at all. They actually really disliked each other because Robert Hooke apparently had a little bit of a hunchback, you know what I mean? And he was a little short, and apparently, like, Isaac Newton thought he was way smarter than he was and stuff like that, and they had a big feud with one another. There's a famous quote that Isaac Newton had after he actually discovered what we're about to talk about here in about, like, 2 seconds, where he said, "Oh, I have only seen so far because I have stood on the shoulders of giants," and he glanced over at Robert Hooke, who was short with a hunchback, and was basically making fun of him with this quote. What a jerk, right? So, like, Isaac Newton, not a nice guy. Also probably a big reason why he never got married. So going into it, though, Isaac Newton, though, being an English scientist, is going to be a physicist and a polymath, right? When we actually look at Isaac Newton, he's going to be the very, very important driving force behind a universal constructed force that's going to bind the universe together. You know of it as gravity, right? And he's going to use mathematics to prove this idea, right? So also, something we need to understand about him, though, as well, is what you would be surprised by, Pierre. Hey, quit licking. Hey, stop it. Thank you. Sorry, we got somebody that's going to, like, lick themselves into a wound if they keep it up, okay? But he's also, this is a weird thing. A lot of people think that you have to separate science and religion, right? And you don't necessarily have to. Something we need to understand about Isaac Newton is he was actually a very pious person, right? Which means he was extremely religious. He also believed in alchemy for a really long time, which is this goofy science where they try to, like, turn certain things into other elements, right? Like basically trying to turn lead into gold and stuff. And they actually believe in all these kind of, like, hibbity-dibbity, goofy, like constructs that we've since disproven completely, right? But it's just kind of important to know that, like, the dude's not, like, perfect, right? Like, so, like, in the terms of believing in alchemy, and he also believed that God had a place in the universe, right? So going forward, though, also we need to understand a couple of events that are going to happen that are going to actually heavily affect his growth as a scientist himself. He's going to actually lead to this entire, like, thing where he, let me rephrase, okay? So 2 events are actually going to lead to a very, very big shift in Isaac Newton's life, right? So he was working inside of this thing called the Royal Society of London, right? And the Royal Society is literally a group of scientists who are paid directly by the crown to actually basically just keep sciencing, right? To dedicate themselves to scientific study. That's why the scientific revolution is kind of a lot like the Renaissance, okay? Because there were all these different little bodies that were actually patroned by monarchies, and monarchs are starting to get really into science because it's actually like, hey, if we invent something cool here, maybe we'll be able to make a profit off of it, right? So going into it, though, he is going to be driven out of the city of London while he's in the midst of his study, and it's because of 2 big events. The Great Plague of London that went down in 1665, and the Great Fire of London that went down in 1666, right on the backside of the Great Plague of London, right? These 2 things are actually going to happen together, and he's going to run away from the city. Fun fact, one of his earliest studies whenever he was actually a scientist was he was trying to figure out the day the world would end, right? And he was convinced that the world was ending in 1666 because it's like the number of the devil, right? 666, right? So going into it, though, while living in the countryside, when he ran out of town away from the Great Fire and the Great Plague of London, he actually began to master his works on gravity and calculus, right? So some of y'all are like, why would we like this guy if he invented calculus? I know, none of y'all like it, but it's still very important, the actual mathematical construct. But apparently while he was living in the countryside, he witnessed an apple fall from a tree. It didn't hit him in the head or whatever, and we also don't even know if he saw the apple fall from a tree. It just could be in a story or an example that he used to explain the ideas of gravitational force to people who didn't get it, right? So, like, now, but he's going to basically define these ideas in a book that he began to work on while he was out in the countryside. It was called the Principia, right? Or the Principia de Mathematica, right? And in this document, he begins to theorize the law of universal gravitation, that the relative mass of an object dictates the amount of gravity that it then gains. So, for example, you had to then have a predictive model that goes on through time, and the only math that can actually be used to prove gravity gravity is that of calculus, right? Because it actually takes one mathematical idea and then launches it forward into the future and predicts its increasing speed or its increasing force or its exponential growth in itself. So he's going to release these findings, and he's going to actually be the guy that is credited with the discovery of the universal law of gravitation. Now, why is this so important? Because his forces of gravity will be the thing that finally proves beyond a shadow of a doubt that Galileo was always right. That larger bodies of mass have smaller bodies of mass that go around them because they are caught in their force of gravity. And we know that the sun is massive, right? Because it can hold 1.2 million Earths inside of it. So we know that we must be going around it in and of itself, right? And then when this actually gets released, he actually gets accused of a lot of things. People say that he's arguing God out of science and stuff like that. He's like, no, God must be there because he's like adjusting everything perfectly and stuff like that. It also is a really, really odd, couple of odd little things that actually kind of equated to his really pious nature. But after he actually releases this book, he becomes the president of the Royal Society of London and the master of London, the master of sciences in London. They dedicate an entire wing to the Oxford College to him, called the Trinity College, which is actually still dedicated to him to this day. And he's later on going to continue his work and expand it into physics, energy, and one of my favorite things about him is he actually constructed the ideas of optical light. Isaac Newton is the man who invented the color wheel, right? The color wheel that you see in your art class, he invented because he was the very first person to realize that white light is actually the combination of the entire light spectrum, right? And of course, he's going to be the one that realizes that those light spectrums, when combined together, will create true white light, and he used a prism to actually separate the entire thing. Now, interestingly enough, though, as you all probably know, the colors on the color wheel, there's only 6 of them. But whenever you talk about the colors in the rainbow, you go Roy G. Biv, right? Red, orange, yellow, green, blue, indigo, violet. But the thing about it, though, is he added indigo. Fun little fact about Isaac Newton, he added that extra color of indigo because he didn't like the fact that the color wheel only had 6 colors on it because he thought that was a mark of the devil, right? So going into it, though, it's a funny little figure Isaac Newton is, and like I said, he never got married because he couldn't really get along with anybody, but he's going to be very important when it comes to linking all those scientific constructs together. But that's right there is the scientific revolution in a nutshell, and we'll talk about it a little bit more later on. I'll see y'all then.